Here we've got chapter 9, sampling design and procedures, and the learning objectives of this chapter is to differentiate a sample from a census and identify the conditions with favor the use of the sample versus a consensus. Now you understand that a sample is like a small sample, but a consensus, we talked about it's, let's say the government do a consensus for the whole city, for the whole state, for the whole government or country, and they go into every house and they collect data, and this becomes information that they gather. So that's a sort of a research. So we will differentiate those two. We will discuss sample design process. We will define what we mean by target population. And target population, remember when we talked about like 4 experiments or 4 research projects. We looked at the yogurt project, and here is like everyone who buy yogurts, right? Maybe in a city. And then we looked into, let's say, people who go exercise, and then maybe we looked at people in a certain age, maybe, between maybe 18 and maybe, 55. Maybe that's a good age for people who go to exercise based on, let's say, the marketing plan of the company's Lady Center or the wider gym. And we looked into, what was the Pampers example, maybe, where the target population would be all the moms. And then we look at determining the sample frame. So who are these people, how we select them. And then we will look into determination of the sample size. So how many people we interview, or how many people we test. Remember with the yogurt, we looked at maybe 20. And then when we looked at the Pampers, we didn't put a number, but we were looking for 10 maybe. The interviews, we were also looking for 5 to 10 people. So here's how you determine these. And then we will classify sampling techniques, probability and non-probability. And then we'll talk about the different types of non-probability sampling techniques, convenience, judgmental, quota, and snowball sampling. So we'll look into each one of these, and we need to understand what each one, how you do it. And then the random, systematic, stratified cluster sampling. And then we will identify conditions favor the use of non-probability over probability. And then we will look at international research, social media, ethical issues, and the use of the internet. And in this sampling chapter, this is like, you remember, this is this has been the research process, step 1, 2, 3. Here we are on this stage of the step 3 before we move to 4, 5, 6. And this is step 3. You formulate a research design. We have looked at these. Now we are here in sampling process and sample size. And these are basic definitions. What do we mean by population? You guys know what's a population. So maybe population is like everyone who live in the city. Census, it involves a complete enumeration of the elements of the population. So you look into the whole city and you check every household or every individual there. Now a sample, it is just a subgroup of this population. So if you want to get the truth about some research problem, then maybe instead of you research like everyone in the society, the whole population or the whole, then maybe you can just take a subset. Now we looked at what's a parameter. A parameter is a summary description of a fixed characteristics of a target. So a parameter denotes the true value which would be obtained if a census rather than a sample was undertaken. And the statistics, it's a summary description of the characteristics of a measure of a sample. Sample statistics is used to estimate the population parameter. So this is what we talked about last class. Now we continue here the differences between a sample and a census, conditions favoring the use. Now, of course, when it comes to a sample, you need a smaller budget. If you ask maybe 300 people, and you go and you send them maybe a questionnaire, it is much cheaper than you go and you do a visit to everyone in a population. At the time, of course, this will be shorter. Population, this is, if the population, population size, this can be a large sample, depending on the size of the whole population. But a census, then you need to go to every single part.
Why are small?
I don't know why it says small, so just forget this small. Population size. So maybe the population. variance in the characteristics. Now here there will be like a big variance because you have like a lot of people, but here it will be smaller. The cost of error, this is like high cost of error, so it will be very expensive for one error to make, but here it will be more low because it's a sample that represents the population. Cost of non-sampling error, so here if you don't do good sampling it will be expensive, but here if you don't do good sampling, you know, if you don't go and visit everyone, you only forget one, maybe it will be okay. And here you need to take the nature of the measurement. This is more destructive and this is non-destructive. This is where we stopped last class, and we talked about, you know, how much damage can happen if you don't do a proper measuring. So here can be big problem if you don't do proper measuring. This will be not big deal. Attention to individual cases, very important to take every individual case because that's your sample. And here, you know, if you have one, it's okay. So this is the sampling design process. You define target population. So we say we want all moms in this society, or we talk about we want all people who use a body or yogurt. Maybe all the ladies in between, let's say maybe all college students, because we're focusing on target. Remember in marketing when you talked about, you know, segmentation and targeting, and so here is like what target, that's what you focus on. You want to determine the sample frame, so how you will select the sample, or, you know, the sample will be from those students, you know, enrolled in those schools. You select a technique, how you will select them. So you're going to take, you know, you will take different methods. You know, one of the methods will be you have all the list of the students and then you select randomly 5 or 10 or 100. You determine the sample size. So that's when you determine 5, 10, 100, 200. And then you go, you execute it. Here we've got the target population. That's just our first step. That's the collection of elements of objects that possess this information sought by the researcher, and it is defined in terms of the element, like the respondents. It says here the object about which or from which the information is desired, like the respondent. So the element, student. You are here a mom. Sampling unit. It is the unit containing this element. So maybe an individual. Sometimes you don't talk to individuals. Maybe you talk to households. So your unit will be household. Maybe your unit is like university. You're looking at universities. Maybe your unit will be company. So that will be your unit. So you're looking at all companies that operate in a city. Then that is your population companies. And then your unit will be one company that you ask or you talk to. Extent, you refer to the geographical. So what, you know, in a city, in a country. Time, you know, when, in the summer. Are you guys okay with these? Okay. Now here the target population must be defined precisely. So the population will be college students. Now that's well defined. Like you have to be a college student, means you're enrolled in some university. It means you have some university ID or some evidence that you are a student. Or maybe target population will be mobile holders. So all the people who have a mobile, so these people, they must have a mobile that works, that they can call to, or they have a number. You defining the target population involves translating the marketing research problem into a precise statement of who should or should not be included in the sample. So remember when we looked into, you know, the problem of, let's say, we talked about Pampers is not selling well, and then we started to look into moms who buy. So here you define we want all the moms who have a kid and or a baby, and the baby age is between 0 and 4 years old. So this is how it's defined, because that's where the problem comes from. So this is like a representation. We've got this is here in the middle. You will have the element. Maybe here females over 18 years old of age. Okay, and then this is the blue, which is the sampling unit. Households with female. So here we're asking maybe the households. So we're looking at each home or household that has this type of female over 18 years old. And then we go to this yellow one, and it says here the extent, maybe the whole country, maybe domestic USA. And then the red, which is the last, is the time frame, in the upcoming summer. Are you guys okay with this? So here we've got the idea or the issue of sampling frame error. Now, how do you make an error? Let's look at this case. Here we've got this target population, which is the circle. Okay, single parent households in Chicago. So here we're looking for households. We're not looking for an individual. We're looking for single parents. Do you know what's a single parent? Like a father with kids and the mom has died or separated, or maybe a single mom with kids and the father died or passed away or separated. And then we look at the sample, and then we've got here the sampling frame, and it says the list supplied by commercial vendors. So maybe there is some sort of a list of all the people who apply. Okay? And then sometimes we can see that some of the people in the list are not single. So this will be like sampling frame error. Do you see? So we got this list of people. This is what we want. This is exactly what is going to be our interest. And of course, these people we can't reach to because these people are not on the list. So this area here, like the intersection between those two circles, is going to be your real people that will be sampled. These people will not be reached while they should be reached. So that's a sampling frame error because of the way we did the sampling. And these people, they are available in the database, but we don't want to talk to them. So these can be part of the error.
Means while we are targeting a specific group of people, we are shifting to another without knowledge or
without paying attention. So this can be a source of error. So it is saying here that
right now it's the green one.
We want the green. We want all the green, but we have this database.
As people are having
so this intersection between the two circles will be the actual sample. But is this the sample that we really want? No. Because we've got here people that we want, but they are not included in the list. And the database that we have may include people who are not really part of our population.
So the list supplied by what means?
This is like where we got it from. It is supplied by vendors. You see, so
from external source that supplied you the.
That's who provided us with the database. Now, classification of sampling techniques. If we look at sampling techniques, we've got non-probability sampling and probability sampling. Do you guys know what we mean by probability? Do you guys remember these?
Yes.
These are the dices. Now, of course, dice is like a representative of it's a pure chance. Okay. So how do we select? We throw a dice, we get a 4, then person number 4 is selected. So that's what we call by probability. It means that there is element of chance. The non-probability, it means there is no chance. Maybe based on our past experience or based on our preference, or we decided to select. Okay, so we're going to discuss each one of these. So here we've got determining the sample size. Now, qualitative factors in determining the sample size, the importance of the decision. So if this is like a very important decision, then we want a smaller sample or a bigger sample. Maybe we want a bigger sample. The nature of the research. So maybe here on this research, it is very important, or there's like critical information, or let's say when they do research about votes and who's going to win the elections, then maybe here because the nature of this research require that we cover this much extent, or maybe this we're going to spend millions of dollars. So here is the sample we'll need to, or maybe it's not really that much, so it's okay if we have a smaller sample. And then the number of the variables. If we have like one variable only, that is different than if we have like 300 variables that we want to measure. Then the more the variables, then the more we need to have people to answer questions.
Does it mean there is accurate?
There is an error. Remember when you do the calculation, there's always an error. And if you remember in your statistics class, you always had that large N, or like capital N and small n, which is like a sample size and the entire population. Then we've got a number of variables, then this will go into the equation in calculating the error. The more we have variables, the more error we will have. And to justify the bigger error, you need to have bigger sample size. The nature of the analysis, how much analysis or what level of acceptable analysis. Remember in statistics when we talked about 95%, 95 confidence? Do you remember this? Confidence interval concept?
Confidence in statistics?
Yes, you talk about confidence interval. Always have like 95% confidence interval. So here is like, this is the nature of the analysis. We want to analyze and we want to be very confident. So that's another issue that determines the sample size. And then we've got the sample size in similar studies. So if all other studies use a sample size of, let's say, 1,000, then maybe you want to be able to have 1,000 so that you can compare. And then we've got this resource constraints. So how much money you have. Because remember, every sample will cost you money. So if you have a lot of money, then you can spend more. Now here are like some example used in marketing research studies, and this is like this general number, or like you can use it like a rule of thumb. Or if it's a problem identification, if we want to find out what's the problem, then maybe we want to have 500 people in sample, and the typical range 1,000 to 2,500 to find a problem. If it's a problem solving, you have a problem and you just want to solve it, then maybe you want to go ask 200,
At least.
and then that's at least a typical 300 to 500. If it's a product test, we're testing a new product, then maybe you want to ask 300 to 500 people, minimum 200. If it's a test marketing study, so you want to see, will this marketing plan work, then maybe you want to check 200 people minimum, 3 to 500. If it's a TV, radio, print advertising, here per commercial or ad tested 150. So if you have like a new test or a new radio advertisement and you want to test it, so you have to talk to 150 people before you put it in the radio. You see, minimum. Test marketing audit. So here, if you're going to go and you check stores, so here maybe 10 to 20 stores, minimum 10. If you want to do a focus group, like at least you need to have like 10 focus groups. Or let's see, minimum 2, the typical from 10 to 15 groups. Are you guys okay with these? These are like general numbers. And
About the test market, it's about
test market, you just want to go and let's see, maybe you have a new product, and instead of you roll it all to all supermarkets in the country, so you just go with 10 stores and you see how it will work. Now here we'll talk about non-probability, okay? So let's see, non-probability. We've got 4 types. Number 1 is convenience. So non-probability, that's when you walk, in the hallway, and then when people come to you, you talk to them. They're easy. They happen to be in the right place in the right time. Judgmental is when you choose. You say, okay, you know what? I will go and ask people in the auditorium, or I will go and ask people in the supermarkets, or I will go and ask the people. So you decide that you want to go to that location, purposeful. And then quota sampling, that's when you set up a quota. So let's see, you want from every class 1 person. Or maybe you want from, let's see, their population here in LIU, we have, let's say, 60% females. Then your sample needs to be 60% females. You see, or 50% females.
Represent the 60 of the population.
Yes, of the population. So in the population here, we've got 50% of the people are 18 years or old. Then you need to have, let's say, if you want to get 15%, 15 years old, 18 years old. Snowball sampling. Snowball is that you go to the first person, and the first person tell you the second person, and then the second person tell you the third person. So that's like a snowball. Are you guys okay with these 4 types?
The quota, please.
The quota, you look at the population and you find some sort of some sort of attributes of the population, and then you want to reflect the attributes of the population to the attributes of the sample. So let's say the population is 50% females, then you want your sample 50% females. Population 20% uneducated, you want a sample 20% uneducated. The population, 60%, have, this much income or more, then you want your sample to have this much income or more. This way the sample really represents the population. Okay? Now we'll look at them more in details. Here we've got this convenience sampling. It attempts to obtain a sample of convenient element. Respondents are selected because they happen to be what? In the right place at the right time. Okay? So you're doing your research at 10 o'clock in the corner of the street. Anyone who happened to be in that time, in that location, will be part of the sample. Here, use of students and members of social organizations like mall, intercept, interviews, department stores, people on the street interviews. So these are like convenient. Now, here, convenience sampling, if we look at this like A, B, C, D, E groups, and these are like the people person number 1, 2, 3, 4, 5, 6, 7. Now, group D maybe happens to be to assemble at a convenient time and a place. So if you know these are all the people in the population, and then you decided to take 5 people, then you will sit on the street and you get these 16 and 17 and 18, 19 and 20. You see? So here happened like convenience. You just found those group, you just interview them or you get them as part of your questionnaire and you finish. Do you see what is convenient? So they're easy for you to get. Now next is judgmental. Judgmental sampling is a form of convenience. So judgmental is also a convenience type. And they're selected based on the judgmental of the research. So you are the researcher, you decide. I want this person, I want that person. It is used good for, maybe it's used in test markets, purchase engineers selected. You want just the purchase engineers. Bellwether, percentage selected in voting behavior, like those people who are like activists. You select experts witnessing, witnesses used in court. So if we are a court and we want to get, so we'll go get witnesses. So we actually selected these people because we believe that these people can have the truth. And the next is, this is like a graphical illustration. This is judgmental. So the researcher considers group B, C, and E to be typical and convenient. Within each of these groups, 1 or 2 elements are selected based on typicality and convenience. The resulting sample will consist of elements like 8, 10, 13, 22, and 24. Note, no elements are selected from A and D. Did you guys understand? So if this is like the whole population, and you wanted to start to select, so you conveniently, you know what you mean by conveniently? You know, because you believe you can do it or it's easy for you. You decided that you will get from B. You decided that you will get from B, from D. From let's see, B, C, and E. So you decided that you want from these people, and then from these people. And then you go and you selected 10, you selected this 13 because this guy is smart maybe, you selected this guy and this guy because these people will, probably give you some information. Okay, so this is how you selected. Are these all? 10, 13, 24, 22, we still have 8. Yeah, so this is what you selected. Are you guys okay with the selection? Now another method is the quota sampling. Quota sampling, it may be viewed as a 2-stage. So here, in a quota, it's like 2 steps. Step number 1, you look at your population. Here is your population. You have males, 48%. You have females, 52%. Then based on these percentages, you want to select your sample to reflect these. So you look at your sample number, and then you decide, okay, since my sample is 1,000, I need 480 males and 520 females. This way I meet the quota, you see. So the first stage consists of developing control categories of population elements. So the control category is like gender, male or female. The second stage, the sample elements are selected based on convenience or judgments. Are you guys okay with this? If you're lost, raise your hand.
A little bit.
Huh?
They are defined well, and we knew the difference between the judgmental and the convenience, but when it comes to the mixed, so
what mixed? In the quota?
They are all mixed. Like the previous table, you said it can be convenient and judgmental.
It is judgmental because you decided. That becomes judgmental. Convenience is because it's in the right place in the right time. So maybe you can go to the right place in the right time. You select conveniently. Maybe you go to the right place in the right time, and then you look at someone. Okay, I want this guy, or I don't want this guy. So you have a judgment.
Not
As you deem, you make a judgment. Now here, this is like an example. Here you have those groups, A, B, C, D, E groups, and you have these number of people. So in a quota, elements from each group from A to E is imposed. Within each group, one element is selected based on the judgment or convenience. So the resulting sample consists of 3, 6, 13, 20, and 22. So let's see, this is 3, this is 6, this is 13, this is 20, this is 22. So here, you wanted to make sure from every group you have one person. And this one person you selected randomly. Not randomly, conveniently. Okay? So here you selected conveniently, and that's quota sampling. This way, you have a quota. From each group, you have one. You guys are okay with the quota?
Can we categorize them as A, B, C, D, E,
like different cities, different companies, different areas? You can do it like different. You see, whatever you want to do a quota.
Which one is different city, different?
Maybe different city. So from every city you select one, or from every bank you select a customer, or from every university you select a teacher. Do you see? So that becomes a quota sampling. Now you go to the university or school or city, and you choose conveniently. So you go, you say, okay, I'll take this guy. I'll take that lead. You see?
So when preparing this table, how can we start up when making this table?
How do you do this table?
Yes.
Let's take the example. We're going to do this study about mobile phones, and we decided that we will ask people about their coverage, and we decided we want to do quota sampling, and we decided that we want to cover Yemen. So we decided, okay, let's look at the Yemen population, 20 million, and this 20 million, then we want the sample to represent the population. So we look, Sana'a is 20% of the population, then 20% of the sample will be from Sana'a. Aden is 25% of the population, then 25% of the population is Aden, so 25% of the sample should come from Aden. You see? So that's how you do quota. You're okay? It's about finding a quota. Now it can be based on location, city, it can be based on gender, you can base it on any other demographic variable.
In the same table.
Now next is the snowball. Snowball, that's an initial group of respondent is selected, usually at random. So you start with random. So you go and you select this guy randomly. And then you ask this person, why don't you go to the gym? And then they tell you, okay, because. Now, who do you think someone else is not going to the gym, but you think this person should go to the gym? And then they will refer to, Mr. X or Miss Y. Then you go to that person and you ask them, you don't go to the gym, but you should go to the gym. Why don't you go to the gym? What is the problem going to the gym? And then they start to tell you the answers. And at the end of the conversation or interview or questionnaire, or you tell them, who do you think also fit this criteria from the people you know? And they will tell you, hey, talk to Mr. W. Then you go to that W. So here it is a snowball. You go, do you know the snowball? Do you see this? It starts small and it becomes big. So here, after being interviewed, these respondents are asked to identify others who belong to the target population of interest. Do you see? Subsequent respondents are selected based on referrals. They also use this like with the internet technology now. You send people the survey, and then at the end of the survey you ask them, please refer 3 of your friends. Then they put the emails of their friends, and then the system will send emails to the 3 friends. And the 3 friends will fill the survey, and when they finish, it will ask them to refer to 3. So maybe you can send it to one person, and then they become 3. Then the 3 become 9, and the 9 become 27. The 27 become, you see, so it becomes like a snowball. Are you guys okay with the snowball? Now this is like an example here. This is illustration snowball. Element 2 and 9. So we start with 2 and 9 are selected randomly from the groups A and B. Now element 2 referred 12 and 13. Element 9 referred 18. The resulting sample will consist of these people. Okay. Note that there is no element from group E. So maybe you will end up from those only groups, not anyone from here. Do you see? So the snowball will be like within a smaller community. So maybe if you ask a LIU student, will refer me to another 3 LIU students, will refer me to another 9 LIU students, and maybe one person will come from another group. Do you see? So that's.
There is space for error. There is place for the errors.
So there is an area for error. There's always, like every single one of these methods, it's got its advantages and disadvantage. Now, of course, these are like when you say it's convenience, you choose the people you want, right? So that brings or introduces the idea of probability sampling. Now, probability sampling, that's when you take the dice and you throw it. So here, a simple random sample, systematic, stratified, and cluster. So I will go through them now, and then we will look at them in more details in the next slide. A simple random, that's based on a dice. Okay, some random. Systematic, it is based on a dice, but there is a system. For example, let's say I will select the first student sitting in a class, and then I will go to all the classes for I select the first one. Or maybe I select number through the dice and I get 11. I get student number 11 from every class. So it's random, and it's from every class, but there is some sort of a system, okay, of selecting these people. Now, stratified and cluster, we will look at them in the slides. Simple random, that's the first one. That's we said is completely based on the dice. And the element of the population has known an equal probability of selection. So in a simple random sample, it means everyone in the population, like all moms, they have the same chance of being selected. Like all the people who are between the college students, they have the same chance of being selected. So if I want to get a simple random sample from, let's say, LIU University, then I will take all students, which is like 1,700 students, put them all, and then I get like Excel to generate, I want, let's say, 200 people to be selected randomly. So I will ask Excel, please generate 200 random numbers. Okay. And I sort all the students, and then I go select these numbers. Are you guys okay with this? Let's see, I'd like to show you how you actually do that on Excel, because we've had like students who wanted to do it, but they actually never did it. Let's see. So let's see here. If these are like the numbers of, let's say these are like the student IDs. Okay. So these are the student IDs. Do these look like a student IDs? So these are like the students of all the university here. Okay, so these are, if we assume this is, let's say, so these are all the students. So now, I want to select from these, maybe 10 students, okay? Or maybe let's say we want to select 3. So I want to get a random number, and this random number will be between 1,000 and 700. Okay. So here I will do this random. Okay. So this will generate a random number, and I want to multiply this number by 1,700. Oh, you don't see? Okay. Let me see here. Do duplicate. Can you see now?
Yes.
All right. So here you want to get this random number between 1 and 1,700. So you will write this function equals rand You open a parenthesis, you close it, multiply it by 1,700. So this is the first number, and you want this like to be an integer number. So maybe you can add an integer number. So this is like the first. So you want, let's say, 20 students. So these will be the 20 students. So you go student number 1,341. You go to student number 1,417. And these are all the students that you want to select, and this will be your random.
The numbers in column E, what does the...
These are, let's say, maybe these are like the student IDs. Okay, so these are student IDs, and these student IDs are like 1,700. You put them all, and then you give a number for each. So the student number 1, student number 3, student number 4, and you have this until you reach the 1,700 students. And then you go select student number 1,560 and student number 291. Are you guys okay how you select random numbers based on Excel formula?
But why you put the ends before the random?
The int is just to make it like an integer. You don't want like decimal places. You don't want student number 12.6. Are you guys okay with this? Alright, so let's go back.